Example 5. Find the coordinates of the intersection of the diagonals of the parallelogram with the following vertices. So we're going to start out. Q is negative 1, 3. R is 5, 2. S is 1, negative 2. And T is negative 5, negative 1. If you have a ruler, use it. I'm going to try to do my best to straight hand this. And then it says find the coordinates of the intersection of the diagonals. So I also need the diagonals from Q to S and from T to R. Now, if I'm looking at that intersection looks like it's about right there. So I could probably estimate or guesstimate that that's at 0, 1/2. But what if it's at 0, 1/3 and my picture's just off? Or what if it's at 0, 1/4 and my picture's just off? How could we algebraically prove that? So we have to think of what's going on. Let's consider here for a minute the diagonal QS. What do we know about a parallelogram and the diagonals? And that is that they cut each other in half. So I know that this is congruent to this. I also know, let's say M, that's point M, is the midpoint. So remember, midpoint or middle is where you take the x's and you add them together and then divide by 2. And then you take the y's and you add them together and divide by 2. So I'm just specifically going to focus on QS and I'm going to find the midpoint. So here's my Q and here's my S. You could also do it with RT, but really you should get the same answer because both of them have a midpoint at the same spot M. So point M, I'm going to take negative 1 plus 1 and then cut it in half. I'm going to take 3 plus negative 2. I'm going to cut it in half. That's going to get me a point at 0 divided by 2 is 0. And then 3 plus negative 2 is 1 divided by 2 is 1/2. So the coordinates of the intersection are in fact at 0, 1/2. Example 6. 3 vertices of parallelogram DEFG are given. Find the coordinates of the remaining vertex. So D is at negative 2, negative 4. F is at 0, 7. So 5, 6, 7. You got to go up here, which is F. G is at 1, 0. Now, it says find the remaining vertex. Well, we've got D, we need E. So first of all, because I could kind of put this in a couple different places, if I need E, D, E, F, G, it goes D, E, F, G. So E cannot be over here. E cannot be over here. E has to be somewhere over here so that I go D, E, then F, G. So I'm going to draw in some lines here because there's a couple ways you can do this. The way I'm going to do this, if it's a parallelogram, is by slope. So I know in order to get from G to F should be the same slope as D to E, wherever it is over here. And in order to do that, I'm going to rise 1, 2, 3, 4, 5, 6, 7. And then I'm going to run backwards 1. So I'm going to do the same thing. 1, 2, 3, 4, 5, 6, 7. And then I'm going to run backwards 1. Then I'm just going to draw the rest of my picture and kind of eyeball it and make sure everything looks about right. I mean, by looks, it looks pretty good. And then from D to G, I'm going to do the same thing. So D to G, I would rise 1, 2, 3, 4. Run 1, 2, 3. Okay, so from E to F better be the same thing. 1, 2, 3, 4. 1, 2, 3. So I know that my sides are parallel because they have the same slopes. So the coordinates of E are -3, +3. To make a parallelogram.